All right, everyone. I know it's been long overdue since we continued these multiple choice questions. I know Unit 5 was a bit of a challenge because there's a lot going on, especially when we're doing test points and all that. But let's just kind of see what these AP style multiple choice questions are going to be like. So let's just kind of get through it. So for number 81, the table above gives selected values for the differentiable function f. In which of the following intervals must there be a c such that f prime of c is equal to 1? So this is pretty much the mean value theorem, right? In other words, we need to know, so it's just usually whenever there is a c involved, that's reminding me of the mean value theorem. And I know that one thing I remember is that the mean value theorem, they're saying that the instantaneous rate of change, I'll write that up here. The instantaneous rate of change, which is the derivative, right? They want to know what value of c does the instantaneous rate of change equal the average rate of change. So hopefully you guys remember that this is over here, like the instantaneous is f prime, whereas the average is f of b minus f of a over b minus a. So, all right, well, let's just go ahead and see, where does the average rate of change? So this is the instantaneous. And then where does the average rate of change equal to 1? So, all right, I know, let me just kind of go off of this. So I know that the bottom is going to be 2 minus 0. And then f of 2 is negative 1. F of 0 is positive 1, so negative 1 minus 1. That'll just give me negative 1. Oh, so that's not it. With that one, I know my denominator is going to be 4 minus 2. So then f of 4 is 5. F of 2 is, no, I'm not asking for f of 7. F of 2 is negative 1. So 5 minus negative 1, that's 6 over 2, which is 3. So it's not that one. And then for this one, I know that my denominator is 6 minus 4. So f of 6 is 7. F of 4 is 5. So 7 minus 5 is 2 over, yep, that does give me 1 right there. If you wanted to test the other point just to be sure, 8 minus 6. And then f of 8 is 5. F of 6 is 7, so that'll give me negative 1. All right, so yeah, for number 82, let f be the function defined as f of x is equal to x squared plus 2x. What is the value c on the interval 0 to 3 that satisfies the conclusion of the mean value theorem f? So again, this is where the instantaneous rate of change has to equal the average rate of change. So, f of b minus f of a over b minus a. So, okay, well, I guess what we can do is we can figure this one out, the average rate of change. That's essentially just going to be, I know that it's b minus a on the bottom, so 3 minus 0. F of 3 would be, let's see, 3 squared is 9 plus 6, so that's 15 on the top. And if I plugged in 0 into all of that, that'd just be minus 0. So I know that my average rate of change is 5. So they want to know, when does my instantaneous rate of change equal my average rate of change? So my instantaneous rate of change would be, so f prime, and they want to know at the value c. So I'll just do it with c. So instantaneous rate of change will be the derivative of that, so 2c plus 2. And when does this equal 5, essentially? So 2c equals 3, c equals 3 halves, or they gave it in decimal form, which is b. For number 83, let f of x be a continuous and always increasing function on the domain AB. Which of the following about f of x is false? So it's a continuous and always increasing function. So I know from a to b, it's an always increasing function. Which of that it's false? Well, the thing is, if you're on a closed interval, from here to here, there's always going to be, and that's I guess that's going off of the definition of extreme value theorem. If your function is continuous on a closed interval, then you're guaranteed some minimum value and maximum value really on there. So it definitely has a minimum value. So that's actually, they're asking which one is false. So it's not A, it's not B, because there is a minimum and a maximum value based off of that. And part C is kind of both of those. So f of x, it's, yeah. There is going to be a minimum and a maximum value if you're on a closed interval and it's continuous in between those two. Yeah, that's about it. All right. for number 84, let f of x be a differentiable function. The graph f prime, the derivative of f, is shown above. On what intervals for all x values between 0 and 9 is f of x increasing? Okay, so this is one where you have to understand the relationship between f prime and f on a graph. So I know if I want to know if f of x is increasing, that means that f prime of x has to be greater than 0. And since this is the graph of f prime, I need to figure out where it's above the x-axis for my graph, right? It depends on what the label of the graph is. Since this represents the derivative, anytime it's above the x-axis would be like right here and right there. So that's at 0 and 4 and from 7 to 9. So, wow, whoops. Hold on, I'll go back to my pen. Here we go. So from 0 to 4 and 7 to 9. Okay, it says if f of x is equal to e, oh, there's some trig, e to the sine of x power on the interval from 0 to 2 pi, then on what intervals is f of x decreasing? So we have to do so here to find out if a function is decreasing, we've got to do the first derivative test. So let's find the first derivative. So f prime of x is equal to e to the sine of x times the derivative of the exponent, so e to the u times u prime. And I need to know, first of all, I guess in order to know whether it's decreasing or increasing, I need to know my critical points first. Yeah, this chapter was not fun. All right, so for my critical points, I'm going to have to set each multiple equal to 0. And the thing about e to the sine of x, unless there's a transformation that shifts it up or down, this is never gonna equal 0 because exponential functions have a horizontal tangent at 0. Again, unless there's a vertical shift. So I don't have to worry about that one so much. But if I look at the cosine of x equals 0, well, if I think about my unit circle from 0 all the way to 2 pi, right, I got to think, okay, well, where does my cosine, in other words, where does my x value equal 0? So I know that there's a 0, 1 here, and I know that there's a 0, 0, negative 1 there. So that means that at the x values pi over 2 and 3 pi over 2, I know that my cosine of x will be 0 because those are the cosines of x. And that's pi over 2, 3 pi over 2. All right, so now I have my testing points. And I don't know why I put arrows there. It's from 0 to 2 pi. So now I got my testing points pi over 2 and 3 pi over 2. So now I got to figure out, okay, they want to know when is this function decreasing, right? So I'll go ahead and explain like the increasing and decreasing. And honestly, you could always go with our trusty, test points right there. But if you know your unit circle really well, you don't really even need that because you know that cosine represents the x values, right? So good thing I know my unit circle well enough. And I know that from basically from 0 to pi over 2, so from this region right there, I know that all of my x values are on the positive x-axis. So I know that all of my cosines are positive right there. If I plugged in my test point into my test point into my cosine, I'll only get positive numbers from 0 to pi over 2. I also should recognize that from pi over 2 all the way to 3 pi over 2, all of these cosines, if you really think about it, are in the negative x-axis, right? So if they're on the negative x-axis, no matter what, my cosine will be negative, whatever test point I plug in there. And then if I use a test point from here, I think you guys hopefully understand the pattern that from 3 pi over 2 to pi over 2, all of my x values are going to be positive. So you're kind of rewarded if you really know your unit circle well enough. So it's really only decreasing between pi over 2 and 3 pi over 2. So that's A. Okay, for number 86, the graph of f of x is shown above. Which of the following statements is true? F of 2, f prime of 2. Okay, so they're only looking at the point 2, and they're comparing f prime, and f double prime of 2. So, okay, well, I guess here they're just trying to make sure you understand what f prime and f double prime, what they stand for. So I know that f prime usually tells me like increasing, decreasing, and usually you can tell that with the slopes. And I know that this one, f double prime, is usually all about concavity. So yeah, I can just look at this function and say, okay, well, first of all, f of 2, that crosses the x-axis, so that's just 0. I know that f prime of 2, Well, that's talking about the tangent slope at that point. And if you look at that tangent slope, I already know that that's a negative value, right? And then f double prime of 2. Well, if I kind of look at point 2, does that function look like it's concave up or concave down? Looks like it's concave up, which means that the second derivative was positive when I plugged in 2. So, yeah, based off of that, I can pretty much answer the question. I just know that, so they're saying which one, they're starting from the smallest. So I know that a negative is always smaller than 0. And 0 is always smaller than a positive number, right? So that's pretty much the order in which they should go in. So that was answer choice C. All right. So for number 87, it says, let f of x be a differentiable function. The graph of f prime, the derivative of f is shown. Oh, is this the same graph we had before? Oh, whatever. So the graph of f prime, the derivative of f, is shown above. At what x value does the graph f of x have a relative maximum? So again, they give us a graph of f prime of x. So you have to make sure that you switch gears and think about the what is the meaning of the graph of f prime of x. So you have a relative maximum when you have increasing slopes and decreasing slopes. So when you go from basically positive to negative. From a positive f prime to a negative f prime. Oops. Set my alarm. Let me turn off my alarms. Whoops. That was distracting. Okay, so yeah, when I go from positive f primes to negative f primes, so I know I'm going from here to here. I'm going from positive to negative, and that's it. 4? No, negative 4. My bad. Negative 4. Okay. That wasn't so bad. So for 88, if f of x is equal to the natural log of x cubed plus 5x squared plus 5, then for what values of x does the graph of f of x have a relative minimum? Okay, so relative minimum. Let's... All right, this is where things are going to start getting long. So now I'm going to go ahead and, for the relative minimum, do the first derivative test. So I'm going to set the derivative equal to 0. So for natural log of u derivative, right, I got to do u prime over u. So the derivative of the inside is 3x squared plus 10x divided by the inside, which is x cubed plus 5x squared plus 5. So there's no point in setting the denominator equal to 0, because if I set this denominator equal to 0, then that's going to make this equal to 0, and we can't take the natural log of 0, so it's already like undefined there, or you have an asymptote or whatever. So I'm going to set, and I'll just tell you right now, almost every time I've seen these problems, the result can be figured out from setting the numerator equal to 0. But I mean, if you want that deeper understanding, then you need to understand just what is occurring there in the original function. So then if I have 3x squared plus 10x is equal to 0, I can factor out an x, and then I have 3x plus 10 is equal to 0. And so, let's see. So basically my critical points are x equals 0 and x equals negative 10 thirds. So they're asking if I have a relative minimum. Well, I'm already going to eliminate this one because it's not even in our answer choices. So I'll just test out x equals 0. And I'm going to guess it's C, but just to be 100% sure, I could always do the second derivative test, and I guess this is a good point to do that. I mean, you can either do like your interval, like with 0 and negative 10 thirds, and test points to see if you have a see like whether it's increasing, decreasing, and see if you have a relative minimum or maximum. But honestly, I would just do the second derivative test here. I think it's quick enough. So with the second derivative test, I'm going to take f double prime of x, which in this case would just be so the other derivative of that, which was 6x plus 10. So then if I just plugged in my my critical value into this, then that means that I'll end up with a positive number. So f double prime of 0 will give me a positive number. And if it's a positive number, that means it's concave up. And if it's concave up, you just kind of, I have to see the picture. If it's concave up, then that means that at that critical value, I'm going to have a minimum. So that pretty much verifies that x equals 0 is a relative minimum. Okay. So if f of x is a differentiable function for all x and has a relative minimum at x equals a, which of the following must be true? Okay, so if it has a relative minimum at x equals a, why am I having a brain fart? It's probably because it's 6 a.m. Which of the following must be true about f of x? So it has a relative minimum. So they're talking about like f prime, right, of x. So if you have a relative minimum, that means that you're going from a decreasing function to an increasing function. So that means that f prime changes from negative to positive. So it's not b, because that says positive to negative. It says f prime of x changes from decreasing to increasing at x equals a. No, f changes from decreasing to increasing. Like if I'm looking at the original function, if it went decreasing then increasing, then I have a relative minimum. But f prime is a different thing. So I feel like most people would choose that one by accident. And then this one, they're talking about concavity. But yeah, this is definitely true, because if you have a relative minimum, that's basically saying that f prime, the derivative, has a horizontal tangent or has a critical point at 0. So I should have just answered that right away, but I was curious about the other answer choices. All right, for number 90, what is the absolute minimum value of y equals 4/3 x cubed minus 8x squared plus 15x on the interval from 1 to 3? Okay, well then I guess for absolute minimum, we have to go ahead and figure out our critical points. And then, God, this is not going to be fun. We have to find our critical points, and we also have to test our endpoints. So all right, well, I guess I'll do the critical points first. So y prime is equal to 4x squared minus 16x plus 15. And to find the critical points, to set that equal to 0. This is not going to be fun. Are they really making me factor this? Yeah. Yeah, they definitely are. I'm trying to think if there's another way of doing this. No, I think I'm just going to have to factor this. Okay. Well, I don't feel like splitting the middle term, so I'm just going to do my guess and check. So I know I have 2x and 2x. I know those two will give me 4x squared. So let's see if I can... Let me think of some factors of 15. The most popular would be like 3 and 5. So I need to have a negative number in the middle, so I can do negative 3 and negative 5. And will that work? If I do negative 3 and negative 5... The outer terms will be negative 10x. The inner terms will be negative 6x. So yeah, that'll work. Okay, well, at least I factored that without a problem. So that means that my critical values are x equals 3 halves and x equals 5 halves. So I'm going to make a table over here of f of x and f of x. And I guess to figure out the absolute minimum, I have to test my endpoints and pretty much test the points in between. So I need to test out 3 halves and 5 halves. This is supposed to be non-calculator. Okay, yeah, this is supposed to be non-calculator. All right, well then I guess I'll plug in 1 and 3. Those are easy enough. If I plug in 1, I'll have 4/3 times 1 minus 8 plus 15 pretty much. So if I get the common denominator, that'll be 4/3 minus 24/3 plus 45/3. There's got to be an easier way for this. So then that'll be this will be negative 20/3. Why did that change into a shape? The heck? That'll be negative 20/3 plus 45 is 25/3. So I know that this is 25/3. I almost want to just jump to that answer. Let me test out point 3 first. No, next, because God, I can't believe they're making me do fractions in this. Oh my God. Okay, so then I'll do 3 3 cubed is 27, so that's 4 times 27/3 minus 3 squared is 9. 9 times 8 is negative 72. And then 3 times 15 is plus 45. So that reduces down to 9. So I have 36 minus 72 plus 45. 36 minus 72 is negative 36 plus 45. So that's a value of 9. And is that... And 25 over 3, that's about like 8.33 something. So I know that it's definitely not going to be 9. God, I'm just wrapping my head around having to do these fractions. And literally the last problem of the 10 that I want you guys to do tonight. Okay, so if I plug in 3 halves into all of that, this is going to get ridiculous. So 4/3 times 3 halves cubed. I mean, I'm trying to think. Is there another way of doing this? I mean, it's definitely not going to be 3 halves. I can already tell you that much. Because if you think about this, the relationship of this, and this might go over your heads, I don't know. An x cubed function with a positive coefficient is going to look something like that. So I already tested my endpoints, but technically 3 halves, that would be a relative maximum just based off of the behavior of the graph. So I'm not even going to look at that one. I mean, this one, crap, it could potentially be 5 halves. Yeah, I guess I'll test that one out. Let me test out 5 halves. So then I'll have 4/3 times 5 halves cubed minus 8 times 5 halves squared plus 15 times 5 halves. Okay, so then this will be 125 over 6, which is, oh my God. So 125 times 4 is 500 over 30? Is that right? I don't even know anymore. No. Sorry. 2 cubed is, I'm sorry. So 2 cubed is 8. So 8 times 5 is 40. Sorry. So then minus, and then this will be 25 over 4 if I squared it. So that's minus 200 over 4. And then this would pretty much be plus 75 over 2. So let's see. I mean, I can try to find the common denominator here, but I would rather reduce this down. So that this will pretty much be 20. This will pretty much be 25 over 2. So this is 25 over 2 minus, I'll just do everything in terms of 2. So 100 over 2 plus 75 over 2. So then that's just going to be 0. So all of that just to get 0. Did I do that right? I'm getting tripped up here. So 125 over 4. Yeah, I'm gonna go with 0. Hold on, let me double check my math here. I feel like I rushed through that. So 125 times 4 is 500 over 8 times 5 is 40 minus 25 over 4. So 25 times 8 is 200 over 4 plus 75 over 2. And then that reduces down to 25 over 2 minus 100 over 2. Yeah, I think it's 0. So that's my absolute minimum. Yeah, that was not fun. All right, that's it. That's 90. I'll stop it there. Just looking ahead, number 91 does not look like it's going to be fun either. Okay, yeah. I'll stop it right there. I'm sorry. This video is super long. Whatever. Enjoy. Bye.